Hello class, this is a video tutorial on solving basic quadratic equations. Now, you may have seen it before or you may have not, but at its most basic, a quadratic equation looks like the following. It'll look like x squared equals some number. Okay, and as we've been talking about it in my previous videos, I solve my equations using inverse operations. And so here we have an operation actually happening, right? The operation happening here is a square. Okay, so if we have the operation of a square, which looks like this. It looks like x squared. It can be anything squared. The inverse of this operation, is the square root, right? And that looks like the square root of x. And now the reason for this is if we have a square, let's take for example x squared, and we apply the inverse, these two actually cancel out and leave us with x on its own. Okay, so with that in mind, let's just do a really quick example here. Okay, really quick example. If we had, for example, we'll stick to x squared. We had x squared is equal to 4. Now, in order for us to get to x on its own, we want to cancel this square. The only way we can do that is if we apply a square root. But remember, like we said, if we apply something to the left, we must also apply it to the right. We get that result there. These two will cancel. We get x is equal to, and the square root of 4, in case you don't know, okay, if you just type it in here, there's a number here, there's a function here, square root of 4, if you equals, you get 2. However, the calculator answer is not enough. Okay, it's not just 2. It's actually a positive or a minus 2. There are actually two solutions here. We have the solution x is equal to minus 2 and x is equal to positive 2. But rather than write it like this, we just keep it as plus minus 2. And the reason for that is if we substitute either the positive or the negative back to the original, we will get a true statement. So for example, if we took negative 2 squared is equal to 4. What is negative 2 times negative 2? Well, 2 times 2 is 4, and a negative times a negative is positive 4. So you get 4 is equal to 4. So this is a true statement. And we already know if we take a positive 2 and we square it, will this become a 4? Well, 2 times 2, well, 4 equals 4. Therefore, both of these answers, negative 2 and positive 2, is a solution for this equation. Right, our equation was x squared equals 4. That was our original. Okay, so now with that in mind, let's get into just a, 3 examples for these ones. So we'll go 1a. If we had x squared equals 9, well, in order for us to get the square root, or to reverse this, we have to square root the x squared. and we get the square root of 9. And whenever you have a square root of a value, you should always take the positive and the negative of this value. In case, again, you don't know, if we just do the square root of 9, we get 3. Okay, we get square root plus or minus 3. Question B, we get x squared equals 25. If you notice the pattern, these numbers that I'm picking are actually very deliberate. We get x squared, we get the square root of each side. Okay, and this will give us the square root of 25. This gives us x on its own. And this gives us positive or minus 5. And finally, question C. We'll go with x squared equals 121. So we get the x squared and we square root it. Square root of 121 gives us x on its own. So square root of 121, that is 11. So these are very basic examples of quadratic equations. But let's move on to what happens if we don't get perfect squares, and what happens if we get really odd numbers. Like for example, if we take 3x squared equals 7. Now that gets very tricky because, well, we can't just square root this, because if you take a look, these, we only have one square on its own without the 3. So how we go about doing this is we divide by 3 first. So we get x squared equals 7 over 3. So I divided by 3 first. And now I square root everything like that. This will give me x on its own. But now we get 7 over 3. See, these do not reduce into anything. So we keep it like that. So we have two solutions. The square root of 7 over 3, positive, and the negative of 7 over 3. Alternatively, you may also write it like this. You can get 7 over 3, each with their own fraction. Each with their own square root. Because that's actually what it means. If you have a big square root like this, it distributes to each one individually. Okay, so let's move on to a few more examples here. If we had 5x squared equals 9. Once again, we want x on its own. We get x squared equals 9 over 5. Square root both sides. We get x on its own. I'm actually going to distribute each of these. So it's going to be square root of 9 over the square root of 5. And there's a plus minus here. And this ultimately will give us, well, the square root of 9 is 3 over the square root of 5. And we'll leave it as that answer there. Okay, we'll just do one more. Question C. If we get 36x squared equals 49. Once again, so we're going to divide by 36, so we get x squared equals 49 over 36. Square root both sides. We get x on its own on the left. I'm going to distribute each one like that. But there's a positive and minus for each of them. This will give us square root of 49 is 7. And the square root of 36 is 6. So we have two solutions of positive 7 over 6 and negative 7 over 6. So let's just do a few more here. Question 3a. We have y minus 2 whole squared equals 9. Now, this seems very odd. Okay, seems very odd, but what we can actually do is, see how I said it in the beginning? These, we said, so long as there's one square on its own on the left, we can square root both sides. Well, we have one square on the left. This, if I just block that, can you see how this entire expression is one square? So what we're actually going to do is we're going to square everything here. So we get y minus 2 whole squared equals 9. I'm going to square root everything like that. Okay, so as a result, this square root and that square will cancel, which leaves us with just y minus 2 like that. And this 9 is now, well, square root of 9 is 3. But remember, there's a positive and a minus here. But now we want to isolate y on its own. So I'm going to add 2. So that's the inverse of this. So if we go y equals, now this is going to look kind of odd, but just bear with me. The plus 2 I'm going to leave here. So plus 2 plus or minus 3. And at this point we're going to have two solutions. I'm going to split this down in the middle. So we're going to take the plus 2s, and this one, watch it, we get y equals positive 2, and for the first one I'm going to take a positive 3. So we get y equals 2 plus 3. So we can get y equals 5. Okay. And then for this one we're going to get y equals that positive 2 again. But this time, so if this were the positive, I'm going to take the negative for this one. Minus 3. Okay, so 2 minus 3 is negative 1. So we have y equals 5 and y equals negative 1. We have two solutions here. This time they are very different solutions. Okay, so let's take a few more examples here. Question 3b. We'll take x plus 3 whole squared equals 16. Once again, this is now on its own, so we're going to square root both sides. So we get x plus 3 whole squared 16. I'm just going to square root both sides. That will leave us that expression inside on its own on the left hand. And 16 is, well, the square root of 16 is 4, but don't forget, it's always going to be the positive and minus of 4. We're going to subtract 3, so it's going to be x is equal to negative 3, because imagine there's a 0 here. I've just moved that positive 3 to a negative 3 there, and this plus or minus 4 stays as it is there. And once again, we're going to split it down the middle here, so we get x is equal to negative 3 plus 4. That's one solution. And we get x is equal to negative 3 minus 4. And this will give us, well, negative 3 plus 4, that's positive 1. And negative 3 minus 4 is negative 7. So x has two solutions. X is equal to 1 and x is equal to -7. There are two solutions for it. Okay, so these are examples of solving basic quadratic equations. Best of luck to you all.